an AI-generated post for your viewing pleasure. Traditional reinforcement learning methods have struggled to foster the kind of reciprocity-based cooperation that is crucial for solving real-world challenges. But a breakthrough new approach called best response shaping could change the game, paving the way for artificial agents that can negotiate, cooperate, and achieve better social outcomes, even in highly competitive environments. In a world of growing complexity and interconnectedness, the ability of artificial agents to engage in nuanced cooperation has never been more important. Whether it's countries negotiating climate agreements, companies coordinating supply chains, or autonomous vehicles navigating shared roads, the need for AI systems that can navigate partial competition, build trust, and find mutually beneficial solutions is paramount. Unfortunately, the powerful reinforcement learning techniques that have enabled AI to master complex games like Go and StarCraft have often fallen short when it comes to fostering the kind of reciprocity-based cooperation that underpins so much of human social interaction. Traditional multi-agent reinforcement learning methods tend to converge on strategies that maximize individual rewards, even if that comes at the expense of overall social welfare. But a groundbreaking new approach called best response shaping could be the key to unlocking more cooperative, socially aware AI agents. By modeling the opponent as an entity that seeks to maximize its own returns, the best response shaping algorithm trains agents to develop policies that not only benefit themselves, but also incentivize their counterparts to cooperate. The results speak for themselves, with best response shaping agents consistently outperforming previous state-of-the-art methods on challenging testbeds like the iterated prisoner's dilemma and the coin game. At the heart of the best response shaping method is a novel detective opponent that learns to approximate the best response to a given agent's policy. By differentiating through this detective during training, the agent can develop strategies that anticipate and preempt exploitation, rather than naively optimizing for its own rewards. Crucially, the authors devised a clever state-aware conditioning mechanism to enable the detective to adapt its behavior based on the agent's policy, even in complex, dynamic environments. This is achieved through a question-answering module that extracts a rich representation of the agent's behavior by simulating its responses to hypothetical game states. Armed with this powerful conditioning capability, the detective can hone in on the agent's weaknesses and devise the optimal counter-strategy. But the agent, in turn, can learn to recognize and neutralize these threats, leading to an iterative dance of strategic one-upmanship. The result is a learning process that consistently pushes both sides towards more cooperative, socially beneficial outcomes. While prior methods like learning with opponent learning awareness and proximal learning with opponent learning awareness have attempted to instill reciprocity-based cooperation in multi-agent settings, they have struggled with key limitations. By only considering a few optimization steps of the opponent, these approaches can be exploited by more complex, long-term learning strategies. In contrast, the best response shaping algorithms focus on approximating the true best response, rather than making simplifying assumptions, allows it to develop agents that are far less susceptible to exploitation. The author's empirical analysis drives this point home, showing how the best response to their best response shaping agents is indeed full cooperation, a stark contrast to the mixed bag of behaviors exhibited by agents trained with proximal learning with opponent learning awareness. Moreover, the best response shaping framework's modularity, with the detective opponent serving as a customizable training harness, opens up intriguing possibilities for further extensions and applications. The author's clever use of self-play with reward sharing as a regularization technique is just one example of how the core best response shaping concept can be adapted and refined to tackle increasingly complex multi-agent challenges. As the real-world importance of cooperative, socially aware AI systems continues to grow, the best response shaping approach represents a major step forward. By demonstrating how reinforcement learning can be imbued with the kind of strategic foresight and reciprocity that underpins successful human cooperation, This work lays the groundwork for a new generation of AI agents that can navigate the nuances of partially competitive environments with greater sophistication and social awareness. The advent of powerful deep reinforcement learning techniques has revolutionized our ability to train artificial agents capable of excelling in complex, high-stakes environments. But as these AI systems become increasingly embedded in the fabric of our interconnected world, their inability to reliably foster cooperation has become a growing concern. Enter best response shaping, a bold new approach that tackles this challenge head-on. By training agents to anticipate and counter the best possible response from their opponents, best response shaping unlocks a level of strategic sophistication that eludes traditional multi-agent reinforcement learning methods. The result is a new breed of AI agents that don't just maximize their own rewards, but actively work to create mutually beneficial outcomes, even in the face of partial competition. Through innovative technical innovations like state-aware opponent conditioning and self-play regularization, the best response shaping framework pushes the boundaries of what's possible in cooperative multi-agent learning. And by consistently outperforming prior state-of-the-art approaches on benchmark tests, this work offers a tantalizing glimpse of a future where AI systems can navigate the complexities of the real world with greater nuance, empathy, and social awareness. As the world grapples with an ever-growing array of challenges that demand collaborative solutions, the insights gleaned from this research could prove invaluable. From climate change negotiations to supply chain optimization, the ability of artificial agents to foster reciprocity-based cooperation will be essential. With best response shaping leading the way, the path towards that future is clearer than ever before.